Everyone, this video is an exercise 9b question 7f. So we're given this triangle and we want to find the values of the two angles x and y. Okay, so first of all we can start by finding the value of angle x because we have enough information in triangle BDC, and we can simply use the sine rule here because it's not a right angle triangle, so we only have sine and cosine rules. However, the cosine rule is not going to work here because we don't have enough information. Because, for example, if we want to find an angle, we need to have the three sides in the cosine rule. However, we don't have that here, so we don't have the side length BD. But we can use the sine rule because in order to use the sine rule, we need to have two pairs of angles and their opposite sides. So one of them obviously is unknown, but the other three have to be known, and that's the case here because we know that B is 80 degrees and the opposite side is 8.5 centimeters, and then the opposite side to x is 6.2. So we can use the sine rule here. We can write the equation sine x over 6.2 is equal to sine 80 over 8.5. That's the first equation, so we just need to rearrange this and then find the sine inverse to find the value of x. So we have sine 80 over 8.5 times 6.2, and then we can just use calculator to find the sine inverse of the right hand side. So of this expression, basically we have 8.5 times 6.2. So the answer is equal to 45.923 significant feet. So that's the value of angle x. Now that we have angle x, then we can find the value of angle c. That's because if you look at the big triangle BCA, so if you have c, then if we somehow find the value of maybe angle A or something like that, then we can use that to find angle Y. So it can be useful. So let's just do that because it's a very simple calculation, so it doesn't take any time for us really. So we can basically do the angle ACB is equal to 180 minus actually it's a wrong triangle, so we are working with this a small triangle. It's basically DCB, 180 minus 80 plus 45.9. Okay, so this is equal to 54.1 degrees, so that's this angle. Again, this might be useful. Okay, now we can look at the second triangle, and when we look at the second triangle, we obviously need to use another sine rule. That's something that is very clear, because normally when we have these types of basically types of combinations of angles and side lengths that we usually have some pairs, then chances are it's sine rule. Right, so in this case, one option is basically using another sine rule, because what we can do here is that the goal is to find a value of angle A, because once we have found A, then the rest is very simple. We can just use the fact that all the angles inside the triangle add up to 180, and then we can find Y. So in order to find angle A, we just need to use another sine rule. So what we can do is that we can form the equation sine A over the opposite side length to that, which is 6.2 centimeters. So remember, we are now working with the large triangle, over 6.2 is equal to, now this angle, so sine C, or just 54.1 over AB, which is 7.5 centimeters. Right, so again, we just rearrange this and then find the sine inverse to find the value of A. So A is equal to 42.1 Let's write that. 42.03 degrees. Right, we are almost done. Now that we have A, then the rest is very simple, because we can just simply do 180 minus, so let's say y is equal to 180 minus the sum of angle AC and then this part of that, which is 80 degrees. So we have 42.03 plus 80 plus 54.1, and we get 3.87 degrees. So that's the size of angle Y, which is very small, and the diagram doesn't really show that, but that's fine because these diagrams aren't exactly like the exact shape.